Hey everybody, John Shutsky here, BSE 508, and I'm going to be talking today about selection methods and looking at different types of design alternatives. And when I talk about design alternatives, I'm going to make an assumption. I'm going to make an assumption that you are an engineer or you're a person who is looking at making some type of a decision. Now, in the case of my engineering class, BSE 508, I'm assuming that you've got a whole bunch of different alternative considerations. It might be a design approach, it might be some component or some system or subsystem, and you're really trying to make a decision. Is this something that we battery power, or do we use a solar electricity or solar generated power? Do we have something that we need to plug into a wall? So something as simple as what type of power source am I going to use for a piece of equipment or for a tool? We really do need methods to make decisions, because if you're working on any type of a complicated system, any type of a complicated design or project, you're always going to be faced with a variety of different decisions, and having some tools in your toolbox to help you make those decisions in the way that an engineer would, putting some numbers to things, being rather logical, being rather systematic, applying things called specifications. All of those can really be helpful. Whether you're an engineer or not, when you make decisions, it's really good to have a framework for making those kinds of decisions. So when we think about selection methods for design alternatives, what are some of the things that you may have to select from, or what are some options you may have to consider in the future? For example, at the beginning of this class, BSE 508, you had to think about the different types of projects you might want to work on. You were probably thinking about, who might the advisor for that project be? How difficult is it going to be? Is it a natural resources project? Because that might be the area that's really exciting to you. You may think about your potential for translating that knowledge you gain in the project to a job in the future. It may align or it may not align. You may also get out of school. You may graduate from school and you may have 4 different job offers, and you're going to have to think about a lot of different criteria. How much does the job pay? Where do I want to live? What are the attributes of the job? Do I think I like the company that I'm being offered these jobs by? And you're going to have to weigh from among a lot of different options. So again, we're faced with different types of alternatives like this all the time. Again, in this class, selecting from among different design alternatives, and oftentimes we're having to make a bunch of these kinds of choices in the design of something, even something as simple as our projects here in 508. It could be a part, it could be a type of sensor, a type of a way that we're going to transfer data. Are we going to transfer it using Wi-Fi signals? Are we going to transfer it by wires, by Bluetooth? So even decisions like that can be complicated, and they also require a fair amount of data and a fair amount of thinking. And if you really want to carefully consider those design options, you have to have done your homework. So I want to talk today about some techniques for how we might do this. There have been a number of examples. About 2 or 3 years ago, we had a project that was presented in this class. People needed to be able to process walnuts. So walnuts are obviously grown on trees. They're fairly common. Walnut trees are fairly common here in Wisconsin. When you grow walnuts, whether they're grown in a domesticated fashion or they're growing on a tree out in the wild, if you're going to eat that luscious nut, that meaty part of the nut inside of the walnut, it takes a lot of work. First of all, the walnut has a rind. It's like a skin. It's thick. It's when it gets ripe, it's dark. It's inky, so it'll stain your hands and your fingers. It'll stain equipment. It badly will stain clothing. So you've got to get rid of that hull or that shell. So there's a lot of ways, even just to do that part of the process. You could mechanically tumble it. You could use chemicals. You could use a high pressure water jet to scrub off that rind. And then once you've got the rind taken off, then you need to think about even different types of technology to actually crack the nut and then again separate the actual meat of the nut from the shell and from all of these different component parts. And you need to be able to do it safely and quickly and cost effectively, and you need to make sure that you don't have any shells in the shelled nuts. So you get the picture. Even a simple project like this, we're faced with a lot of different alternatives. I've done a fair amount of work, and I actually like doing this type of work where you're having to choose from among design alternatives. I'm going to come back and talk about this particular project here in just a few minutes. But in the mid 2000s, probably around 2005 or 2006, we worked on the design and development of a system to sense or detect people walking into a dangerous area located between a tractor and some type of a power takeoff driven implement. In this particular project, we looked at walking into a protected zone or getting too close to the rotating shaft hazard between a tractor and a self-unloading forage wagon. And we were faced with all kinds of alternatives. If we want to detect people using automatic sensors and detection, we could use radar, we could use microwave, we could use infrared, we could use video cameras, we could shoot sound waves out with a sensor and look at the reflected sound waves to see if there's any type of reflection, or if we can sense a person using what they call ultrasonics. And all of these different approaches, they're all very different. They all cost different amounts of money. They have different levels of effectiveness. In the end, and I'll come back and talk about this, we ended up designing a system that worked really well. It met all of our specifications, and we actually won an award for the research paper that we wrote on this. And there are some of these technologies currently being deployed on machinery like farm machinery. So as you do this kind of work, as you are working on selection of pieces, parts, components, subsystems, systems themselves, I would like for you to think of these tools that I will be presenting to you as ways to learn more, to further develop, to refine concepts, to refine ideas, to innovate. And I think also in the end, one of the things that's important is that you do this as a team, because as a team, you have some collective wisdom with many people thinking about the same issue and the same problem. And so I think it's just really important to think about some techniques that everybody can work on together and that you can agree to. And by the way, I want to just say, when we look at evaluating different alternatives, it's not an issue of who wins. You know, we each come with our own ideas, with our own proposals, our own way of wanting to do things. It's not about who wins. It's about choosing the best approach, or possibly combining approaches through this process. The value is in the process. Through this process and through iterating over and over again, you may actually start with a collection of ideas, and through the process, it's a way of innovating, because you might think of something that's entirely new that you hadn't originally thought about when you brought it in to this process that I'm going to ask you to work on. It's about evaluating, again, approaches, concepts, components. It does require good information. So if you're going to sit down with your fellow teammates and you're going to go through this process, you need to come prepared. You need to have done your homework. You need the data, the information, the drawings, the specifications, the actual cost. You can't just guess at things. You actually do need good data. Your decisions, your final decisions, and your selections and your choices will only be as good as the data that you bring to the table. And again, as I always talk about, like when I had you talk with your customers as part of the homework assignment here in 508, don't isolate yourselves. Don't insulate yourselves. Make sure you're getting data and feedback and iterating with your customers and with your stakeholders, because obviously they're the ones ultimately that are going to purchase your product or your service or your design, and getting their input is really crucial. So here's kind of what we're looking like. We oftentimes talk about the concept development funnel. We spend a lot of time upstream in the early phases on the far left-hand side of this picture, doing a lot of research, understanding what those standards and specifications are, and informing our creativity by looking at patents and intellectual property. But eventually we begin to develop some ideas, some alternative concepts. And the idea is we can't really start out with 15 concepts and then just all of a sudden emerge to one final product. We need to go down through a process, and we need to make decisions. We need to narrow the scope. We need to narrow our range of alternatives. Again, in some cases, it's not just about throwing things out. It may be about combining two ideas into one new one. But you get the idea that as we move from left to right, ultimately we're making decisions and we're developing something, we're prototyping, or maybe then going back with that prototype and reiterating and maybe redesigning some parts or some subcomponents. So the process is really what's important. And you need to start, again, with good data and good information. What I would like to talk about here is four formal, informal, I'm not exactly sure what to call these, but four specific techniques. I'm actually going to add a fifth one called a SWOT analysis. We'll get to that in just a moment, but I'll talk about voting, simple voting, having multiple votes per person, having a screening matrix, and also looking at specifications and concepts and weighting things. So lots of different alternative ways of doing this. Again, I'll add the fifth one in, and the fifth one will be the SWOT analysis, SWOT. The first idea, and this is where a lot of teams start, is maybe we have 2 or 3 or 4 alternatives, and we have a team of 5 or 6 people, and we just ask people to vote. That can be complicated because sometimes there's really, maybe you want to cast your vote for something that's your favorite, but maybe number 2 is your favorite. You've got 5 total. Number 2 is your favorite, but man, there's just some stuff about number 5 that you really, really love, and you hate to give up on that. So simple voting, if I'm voting between, or I'm choosing between 2 different alternatives, if I've got a team, if I have a selection committee, if I have a board of directors, a simple vote may be perfectly adequate, but it is tougher when you have multiple alternatives. So don't forget about the idea of simple voting, but there's some degree of limited utility. It can also be difficult if you've got some complexity in the choices that you're making. And I want to just use this, simple little example, and this would be really typical of something. I've seen groups of students do this. You're at a national conference, or in 2022, our ASABE conference is going to be in Houston, Texas. And there may be some of you who are in this class who end up going to Houston, and you're with a group of students. The students will probably not just be from Wisconsin. You'll be meeting students from California and Texas and Florida and all different areas of the country, probably even different parts of the world. And there will be groups of you, I guarantee this will happen, there will be groups of you who want to go out to dinner together, because that's one of the cool things about going to big city. You're in Houston, Texas, and you want to go out to eat. You've had a long day of sessions, and maybe some of you have interviewed there for jobs, or you've talked to potential future employers, so you're excited, but you're also tired, you're exhausted, and you're ready to go out and kind of kick loose. So one of the things that happens is if we do simple voting, it can be difficult. Let's just say we have a group of 12 students. We know that 6 of the students are vegetarians. So the question is, how are we going to find, where we're going to go? So somebody comes to the table, or maybe you go to the, what's it called at a hotel, the concierge. You go to the concierge and you get some menus and you get some recommendations from the people at the front desk of the hotel. And you've got, what do you have here? You've got 4 different options to choose from. You've got Bill's Steak and Chop House, a really great name for a Houston, Texas restaurant. You've got an Indian restaurant that has a full menu, Cafe Namaste. You've got Roots and Shoots. Roots and Shoots is strictly vegan and vegetarian. And then last but not least, you've got a restaurant called Real Food Daily that has a full menu. They got lots of vegan and vegetarian options. And you just say, okay, we're going to vote. Hands up in the air. Everybody gets one vote. Where are we going to go eat? Well, you can see what happens if, by narrow victory, if Bill's Steak and Chop House wins out in this cluster of 4 different restaurants. Potentially you've got 6 people who are either not going to go, or they maybe feel like they're going to be left out, or they're maybe they'll go along with you and order something to drink, but they're probably not going to eat anything, or maybe they're only going to order the French fries and the coleslaw. But you get the picture. It is a simplified technique, this idea of one person, one vote, that can leave people out. So one of the things to think about as you're doing, whether you're voting with 1 vote per person or 10 votes per person, you may also want to think about What else do I need to know if I'm going to cast my vote, or if I'm going to even go ask the concierge at the hotel? There may be some criteria, right? These are just like your project design specifications. You may want to think about things like cost. So if they give you 4 menus at the front desk of the hotel and say, here's 4 really awesome places, one of the screening criteria might be cost. It might be location. Chances are, if you're all in Houston, Texas, you're going to walk, or maybe you're going to take an Uber. So what that means is you probably don't want to find some place that's 15 miles away from the hotel. So location is going to be important. Waiting time. Perhaps you've got somebody who you're going to go out to dinner at 6 o'clock, but they have a job interview at 7:30. So you want to be able to go there, eat, maybe have a drink or something, and then be back to the hotel by 7:30. Menu items, we've already talked about. Other attractions nearby, typical clientele. When you do this kind of thing and you're at a national conference, you want to think about safety. Is it going to be in a safe neighborhood, especially if you're going to walk there? So again, this is why taking it back to senior design, taking this back to BSE 508, this is why I have you spend so much time on your project design specifications, because your specifications really help guide and direct your decisions. They are largely your decision-making criteria. They may not all have equal weight, but they will help to influence and determine what your selections and what your choices might be. Another option of doing this is to give people multiple votes. So maybe you are working on a design project and you've got 7 different alternative design concepts, and you say, got 5 team members, I'm going to give each one of you 5 votes. You can put those votes wherever you want, but we want to just kind of find out where's the collective energy in this group. And if you give everybody 5 votes, they're, sticky dots. You go to Staples or Home Office Depot and you can buy these sticky dots. You've got big charts, flip charts around the room. So you can see here, concept number 3's got a lot of votes. Concept number 1 isn't doing too bad. And concept number 7 has also got some votes. So, we've got maybe 3 areas here. Like, there seems to be a lot of energy. So it kind of gives you an idea of where you're heading. Probably concept 1, 3, or 7 is going to kind of get you someplace. One of the things you might want to do in a situation like this is actually, let me back up. In a situation like this, you might say, 1, 3, and 7, some really good energy. And maybe you say to the people who voted for 2, 4, 5, and 6, we're going to throw those out. We've got a total of 1, 2, 3, 6, 7, 8, 9, 10, 11. We've got 12 votes. We're going to give you back your 12 votes. And if you had a chance to recast your 12 votes in 1, 3, or 7, where would you put those votes? And it may give you a little bit better of an idea where a consensus might be developing. Or another way to do this would be to say, concept 3, that really shows promise. We got a lot of votes. We got a lot of people. But, okay, so those of you who voted for number 1, talk about that. What are some of the elements? What are some of the things you really loved about concept number 1? And might we be able to bring some of those ideas into concept 3 and make concept 3, which is already pretty strong, make it even stronger? And the same with number 7. Maybe there's some really cool stuff in number 7 that we might bring up into number 3, so that number 3, because there's already a lot of energy there, ends up being the best of the best. You've got all the stuff that was in 3, but you borrow some stuff out of number 1, you borrow some stuff out of number 7, and now you've got a truly great solution. And you started out by giving people some choices, giving them some weight, giving them some places to place their weighted vote by voting with multiple votes per person. That's perfectly acceptable. If that's the approach that you use in 508, 509, you'll also find that that's really common out in industry. I've done so many like flip chart with dot voting exercises, and it tends to work really well, and it tends to generate a lot of conversation. It tends to generate a lot of ideas. And that's really what we're trying to get at. It's not like, okay, which of those yellow sheets do we want to get the most sticky dots onto? The idea is the process. The idea is refining ideas, discussing, being creative, innovating, combining ideas, combining approaches. That's really what it is that we're trying to do. Another thing that we oftentimes do advocate, and a lot of you will probably do that in this class, is a decision design matrix. I believe this gets talked about in other design classes that you may have had exposure to, where you basically start out by using your design specifications. And let's just say in this particular case study, you've just taken a summer job. You're going to work here on campus, and you're going to live about 6 miles away. Obviously, if you get further from campus, housing is a little bit cheaper. Apartments can be had for a little bit less rent. But 6 miles away from the campus is a little bit of a challenge. It's probably a 2-hour walk, maybe an hour and a half. So probably going to be a little bit difficult to walk to. So the question is, how am I going to get to and from work? I've got to work. I've got to be on campus every day. I've got to be there maybe 8 o'clock in the morning, which is pretty typical. So your criteria for choosing the right, mode of transportation might have these objectives or these criteria. Or again, these project or product design specifications: travel time, cost, comfort level, flexibility, reliability, safety is really important, productivity. If you are going to spend a lot of time, can you be productive while you're doing it? There may be some interest in something that's going to add to your health, something that provides privacy. If you're on a bus, you've got a lot less privacy than if you're in your own personal vehicle. And then also a lot of us think about green. Is this something that I'm going to have a minimal footprint on the environment? Am I going to, not burn a lot of fuel, add to the carbon load of our atmosphere? So green, sustainability, and being environmentally friendly. If you think about it though, this is not quite enough. You probably also want to weight these criteria. For a lot of us, productivity may not be as important as my cost. So you may want to give this a weight. And in this scale, this would be perfectly acceptable as a way to weight your alternatives or your design processes. And again, there's a homework that relates to this assignment, but you might give them a weight on a scale from 1 to 10. It's a little bit arbitrary. Obviously, 10 is like really important. 1, not quite as important. So travel time, like I don't want to waste a lot of time. I got to be at work by 7 o'clock. If it's going to take me 2 hours, that means, well, if I've got to get to work by 8 o'clock, if it's going to take me 2 hours to walk to and from my workplace, that means I'm going to have to leave at 6, which means I'm probably going to have to get up at 5:30. So time is pretty important. And again, you can go down through. I've arbitrarily, for the sake of this assignment or this lecture, I've just arbitrarily assigned the weights. Safety is important. You could argue, well, maybe safety should be a little more important. The cost. This is why data is important. You really do need to think about, okay, what's the true cost? I know that I can get a bus pass at either a really low cost, or if you're a student, perhaps even not have to pay money at all. Probably more like a low cost pass. If I have a car, not only do I have to pay for car, but if I'm parking on campus, I've also got to pay for parking. So you want to do your homework. What's it going to cost me to park here during the summertime? And by the way, it's like $8 a day. So you'd want to factor in the total cost of your transportation. But again, the weighting is what's important. You've got your project design specifications, or in this case, your transportation specifications. You've got a weighting. And then obviously you've got your different alternatives. You could take a bus. You might want to get a moped or a scooter. You could carpool. You may have a roommate, or you may have coworkers who might be able to stop on their way in, pick you up. You've got maybe the option of taking a bike, just a regular old bicycle, pedaling on in. You could have 2 options. You could have a regular old pedal bicycle, and you could have an electric bike now. Or you could walk. I suppose we could add run. We could add other alternatives. We could Uber would be another example. So you want to make sure that your realistic alternatives are spelled out. And then obviously what you do is you rank these based on how well do they fit the criteria. This system would work well, weights from 1 to 10, and then how well things fit each criteria. Maybe your scale is 1 is bad, low, and 5 is good or high. So you can see I've just using my own subjective information or my own subjective thinking, I've gone ahead and ranked. And then obviously what you're going to want to do is multiply the weighting factor times the rank from 1 to 5, and you're going to come up with a total score. Now, before I show you what that total score might look like, one of the things to consider on this is I mentioned it's subjective. Like, this is just me. This is just the Schutzke data here. And if I'm making this decision and I've got 5 people who are part of the decision, you probably are going to want to have some discussion. You're going to want to really talk about, okay, travel time and scooter, is that really a 4? Like, how fast can I go on the scooter? What if I've got other types of issues? What about traffic? So all of the criteria and all of the other options, you're going to want to spend some time debating, discussing, maybe coming to compromise, maybe eventually landing on a consensus and saying, okay, bike travel time, we'll give that a 2. But the idea is it's that conversation, it's that process that has value. Again, as I talked about, you multiply your weighting times your ranking factor from 1 to 5. You come up with a sum for each one of these columns. And this one, it's actually, it's fairly clear. Bike is pretty good. Bike comes up with a total ranking of 176. Let's see, we're 6 miles away. I could probably bike in at a speed of 12 to 15 miles per hour. So it's going to probably take me about a half hour. That seems reasonable, right? But one of the things you might want to think about, there may be some issues or there may be some situations where, if I've got a driving thunderstorm and a 35 mile an hour wind when I wake up at 6 o'clock or 6:30 or 7 o'clock in the morning and I'm thinking about biking to work and I've got to be there, that's not very cool. So then you might want to think about maybe I need a backup. Car, my backup from a perspective of looking at my chart here, my car would be my natural backup. Car may or may not be an option for you. If you drove the car, you would obviously, again, need to be thinking about parking. But then you think, maybe there's an alternative solution. I'm still going to bike as my primary, but my backup is going to be in a car. Carpooling didn't do very well because carpooling, people want dependable carpool passengers. They don't want people who are only going to ride with them when it's raining. So maybe your carpool is an Uber or a Lyft. I'm going to primarily bike in, but I've got this backup partly based on my design matrix. And that backup is going to be, I'm going to go in a car, but I'm going to go with somebody else. I'm going to pay the money. I'm going to pay $6 to get in. I'm going to pay $6 to go that 6 miles. But instead of having to park and spend $8 on campus, plus my gas, plus the expense of having a car, I'm going to still be in a car, but I'm going to take an Uber. So you get the picture. Now let me go back to this this example. This is basically just different colors, but this is the tractor and implement where we designed a sensor-based system to provide a visual and audible alarm, a buzzer or a bell. And then also we physically designed a system to totally shut off the power to the machine. Again, using sensors and different types of input devices, using computer control. In this case, we actually used a laptop to do our research so that we could measure response times and reaction times, and we could log all of our data. But in a real life situation, you'd use a circuit board, or you would use a smaller, much more small, probably an Arduino or a Raspberry Pi or some other type of smaller computer system to make the decisions. But the question was about the sensors down at the lower right-hand corner. Sensor A, sensor B, sensor C. We looked at a range of different sensors. But before we began to prototype, before we began to actually put a system together, we did a design matrix. This design matrix that we looked at is a little bit different. And let me just explain this again. This might be a technique that you use. You see that what we were looking at in the upper part of the chart here, or the table, we were looking at sensor technology. So we had passive infrared, microwave, radar. We had ultrasonic or sonar. We had photoelectric. We used something called infrared, breaking a light beam like you might find in an old style elevator door. Capacitance sensing, where you sense the capacitance of a human being as they approach. And then we also used we looked at video imaging using cameras, using image processing technology. But then we had a bunch of criteria. We wanted a sensor system that would be robust. It would reliably detect people. It would not be prone to false alarms. And those were all givens. We also wanted it to be robust in all of these different environmental conditions. So dust, temperature extremes, humidity, noise, things like ultrasonic is obviously sensitive to noise, contamination or noise, maybe fooling a system, vibration. We wanted something that would withstand moisture, rain, sunlight, background motion. So obviously, if you've got a video image and you're looking at the presence of a person walking in, but you've got a bunch of stuff going on in the background, that's not going to work very well. We had also done a ton of research. So what you see, the numbers that are represented in this table are zero. Basically, the literature, the research says like, yeah, if you look at video imaging, far right-hand side, lower right-hand corner, yeah, reference number 7 just said for background noise, video imaging is just not going to work very well for us. Number 1 was, yeah, we might be able to use it in this situation. It may need some adaptations. We may need to combine it with another technology to be fully robust and workable. Number 2 was like, yeah, this might be really good. The literature, the research, the articles that we read. So you see that there's a lot of 1s, there's a lot of 2s. It ended up that we went through this really deep, this took us probably 6 months, or at least the better part of a summer, and then about half of the fall semester. There was no one single technology. Like if you go down through the list and you look at passive infrared, you got a lot of 2s. It's like, yeah, for a lot of these like high temperatures, yeah, it's going to work pretty well. Low temperatures, it's going to work pretty well. But when you get down to things like rain or sunlight exposure in some of our references, it's not going to work all that well. So what we ended up doing, and I mentioned that we won a paper, a research paper award, and then some of these technologies are now being applied in different types of industrial and construction machinery and equipment, is we ended up saying none of these is perfect, but you know what? It actually looks like passive infrared and radar is going to work pretty well for us if we sort of merge and combine those technologies. So that's what we ended up doing, is looking at combinations of sensors, or what we called sensor fusion. Again, this was back in the early 2000s. That was kind of a new idea, but now a lot of sensing technologies are using these kinds of methods where they're fusing or they're combining the best of the best, because no one single technology is going to work perfectly in all applications. But my point on all of this is only made possible because we did a very robust evaluation. We brought data to the table, both the table physically, but also in this particular table where it shows the data. And it helped us to make the best decisions that were possible given the design problem and the solution that we were looking for. In our case of this sensor project, the highest scoring technology might not have been the best. The 0 said like, probably not going to work very well. And again, as I talked about, we did some combining of ideas. And that's really what I want you to think about for this class, is using the process to come up with even better ideas than coming as individuals with your own separate data points. Combining ideas through a process or a technique or an activity like this, that's what design is all about. You come up with creative ideas, you innovate, you brainstorm, you document, you get the data, you bring it to the table, you maybe have to do some calculations or collect even more data. But in the end, you use your thinking, you use your evaluation skills to make logically thought through, mathematically based decisions. Not big time math, and this is simple addition and subtraction and multiplication, but you get the point that we're using a replicable technique, but we're also using the skills and thoughts and knowledge and creativity of our team members to do everything. Little bit of an adaptation of this. This is actually, you'll also see this, it's called the Pew Method. Pew being spelled P-U-G-H. P-U-G-H. Professor Pew was a engineering design professor. Basically, it's the same idea. You've got the same, in this case, the same objectives or the same project design specifications. You've got weighting. The weighting here is a little bit different. But what you do instead with the Pew Method is you you look at one of your options that you might think to be the best. So to me, if I'm driving 6 miles or if I'm traveling 6 miles every day, I'm that student, I might think, I think the car is probably going to be the best. But then what you do is you compare all of your alternatives. So car, in this particular instance, becomes your sort of benchmark, or what Professor Pew called datum. And this is the only place I've ever heard the word datum, datum, datum. So he sets car equal to datum. I'm sure if you look this up in the dictionary, you'd find a good definition. But then he says, I'm going to compare everything to a car. If it is equal to, I'm just going to call it a 0. If it is worse than, I'm going to give it a minus, essentially a -1. And if it's better than, I'm going to give it a positive. I don't need to worry about how big of a positive because I'm going to do the big with the weighting. So then you end up multiplying. So let's just say bus for low travel time is actually -1. I put minus, but we're talking -1. So that's going to get a -3. Low cost per trip is going to get a +3, so that's going to cancel each other out. But in the end, you add up these columns and you compare it to the datum. The datum is always equal to 0. And so in this case, it looks like car and walk is kind of about equal. And so what you end up doing is like, that doesn't make a lot of sense. So what you do is you try the datum on other options. So let's maybe move the datum over to walk, and we're going to compare everything to walking. Now, if you do that, you're going to probably find that a car is head and shoulders above walking. And you essentially replicate this a few times. You switch the datum, and you see after one run through, you change the datum to the best, and you rerun it. In this case, we're going to change it from driving to walking. We're going to rerun it. And we're going to say, okay, do these ideas still persist? Does that best solution still persist? And in some cases, yeah. In some cases, through running it multiple times and kind of moving that datum around, there will be an idea that will emerge clearly head and shoulders above others. And again, it's also an idea of where you might be able to, you have a couple of them that keep tying, like we did earlier with I don't even remember what it was, but where we had one option, I think it was riding your bike, and then the backup option was taking an Uber. So perhaps through this process, if you have things that continue to tie, maybe you can find the best of the best by combining those two options. So it's really similar. I tend to use just the weighted decision design matrix. I think the datum for me feels a little bit goofy, and you can accomplish the same things by just doing raw scores. And then from your 2 or 3 highest, thinking about the best of the best from your highest scored and trying to extract subcomponents or parts of the best and combine them into a new option. It may not be as easy to get that with the Pew matrix. I think I just have like 1 or 2 more slides here. Some teams may want to think about their design alternatives using a SWOT analysis. SWOT stands for strengths, opportunities, weaknesses, and threats. Or if you do it in the right order, strengths, weaknesses, opportunities, threats. SWOT, SWOT. And the idea here is you have maybe a more limited number of options. Maybe you have 4 different options that you're looking at. Let's just say back to my sensor design, looking at this sensor system between a machine and a rotating component and a tractor. So maybe we're going to look at infrared versus microwave, and we're going to look at the strengths of each. We're going to look at the weaknesses associated with each. We're going to look at maybe what are some opportunities with microwave. Just as an example, we know microwave has lots of applications. When I walk towards a door of a grocery store and the door automatically opens, it's probably using microwave. So there may be some opportunities to use that on other applications on the farm, as an example. Threats, you may have something where there's a threat associated with that particular alternative. Perhaps it is a safety problem, or perhaps in the case of riding my bike 6 miles to and from my office every day in the summertime to have my summer campus job, the big threat of riding my bike is the weather. So, you'd really want to think a lot about what are our backup plans then, or how can we maybe design in some additional considerations to accommodate the threat. I know that the project that is working on dairy related technology, the client you're working for will probably have you do a SWOT analysis, but there are some other ones, some other groups who may want to explore the same options or alternatives. If you'd like for me to provide you with a little bit more information on SWOT analysis, I can help you with that, or I could help you get lined up with some more expertise to help you go a little bit deeper. So this is my last slide. The key points in evaluating design alternatives. The true value is not what gets the best score. The value is in the process. Again, I have said this probably 20 times. The value is in going through this exercise. And this is why I'm having you do it as a team. It's because that team communication, each team member bringing its ideas, its data, its thoughts to the table, having a voice is what's really important. The deep analysis, though, does require a thorough understanding of the problem. It also requires a thorough understanding of your design specifications and the potential solutions. And it really does take data. And I've talked about this. If you're coming in and you're making crude estimates on the cost or the maintainability, or how long is it actually going to take you to get to and from campus with your new job in the summertime, if you really don't have good data to help you make these different decisions and weigh these different criteria, it is going to be really difficult. And then finally, this process takes teamwork. This is why we have you. This is probably the most important part of why we are having you work together as a team in this class, because out in the real world, this is what engineering design teams do. There's no secret. There's no magic formula to being an engineer. You've got to be really good at math, and you need to know basic physics and thermodynamics, heat transfer, those kinds of things. But it's this kind of teamwork, working together, developing a mutual understanding, communicating. In some cases, you may have an alternative that you really are in love with, and you need to sell it. You need to communicate. You need to show your passion. You need to have the data. And I'm not saying to ever bully people or to try to overwhelm other people, but really being an advocate for maybe an idea that you feel really strongly about. This is the place where you can bring those ideas and that passion to the table. So I almost consider this to be the most important lecture of the semester. I hope that you take this seriously. I also hope that you take this and run with it. I know that there are a number of teams that will be considering a whole bunch of alternatives. So do take it seriously, because this is where the fun stuff is. This is where you can really differentiate yourself in the marketplace. Again, let me just mention that there are some LinkedIn learning modules that kind of support and build off of the things that I've talked about in terms of innovation and creativity. If you're here on campus, if you're enrolled as a student, you have free access to those. Please see my Canvas course for the specifics and for the details. And for those of you who are not on Canvas, or campus, I should say, it's also available. It's just that you'd probably have to pay a small amount. And the module, it's actually 8 one-hour courses, is called Develop Your Creative Thinking and Innovation Skills. So a lot more detail, even more detail than what I've gone into, and even more detail in the upfront parts of doing the brainstorming, doing the teamwork, bringing those innovative ideas and solutions to the table. I hope you enjoy this, and I will talk to you all soon. Look forward to seeing your homeworks in this area and how you go about developing your alternative designs and then coming up with the optimal solution.